This video describes a replacement for the trajectory clustering program that is supplied with the HYSPLIT distribution. If you have been satisfied with your results using the standard distribution approach to clustering, then there is no need for change. The new method described here will give you slightly different results, which I will discuss in more detail in the next few sections. But more importantly, and the main reason why I developed this revised approach, is that it runs much faster, and it has a more modest memory requirement, thereby permitting the clustering of a huge number of trajectories in a single execution of the program. The HYSPLIT clustering program is not just one program, but a series of 7: cluster, cluslist, clusplot, clusmem, merge list, trajmean, and trajplot. And they're all linked through scripts that have been provided, either in the graphical user interface, which also contains detailed help information, the testing directory with a sample script, or the online tutorial with a link to yet another script. You should be familiar with the standard clustering script options before proceeding, because the revised program can only be run through a script. Review the Cluster 2 program webpage for all the details about the new computational approach. The revised clustering computation works in a manner similar to the clustering program distributed with HYSPLIT. Trajectories, or mean clusters, are merged together if that pair has the minimum spatial variance compared to all other pairs. The main improvement is that Cluster 2 uses a first-guess solution to permit a faster convergence rather than starting with each trajectory in its own cluster. Initially, all trajectories are assigned to a first-guess cluster. Unlike the standard clustering program, the final number of clusters desired has to be preset. The program is fast enough that multiple solutions can easily be computed. You will need to download the program, which is written in Fortran, compile it on your system, and then place the executable in the HYSPLIT/exec directory so that it will work with the sample script provided, which you should also download and probably rename from .text to .sh. There is no need to compute any trajectories to test your compilation. In the standard HYSPLIT distribution, the testing directory contains a script, xcluster example svg.scr, to cluster the sample trajectories in the HYSPLIT/cluster directory. We will use the SVG rather than the PostScript version. A revision of this script, xcluster2 example svg.scr, will cluster the same trajectories using the faster Cluster 2 program. Download this script and place it in the testing directory. You probably will want to rename the suffix from .text to .scr. Comparing the two scripts, the program cluster in the original script was replaced with program cluster 2. And the calls to clusplot, clusend, cluslist, and any of the intermediate file existence tests that might cause the script to fail were commented out. Run both scripts. The resulting mean clusters for the original clustering program are shown in the file cluster.html, while the results from the new program are shown in cluster2.html. A cursory view of the cluster mean trajectories shows them to be very similar, but there are some substantial differences in the frequency of clusters 3 and 1, 34% versus 15%, and 21% versus 37%. The individual trajectories composing each cluster mean explain the difference. The trajectories within clusters 1 and 2 have very similar characteristics. However, in cluster number 3, the standard clustering approach contained trajectories toward the northeast that clearly belonged in cluster 1 or 2. This accounts for the larger percentage of trajectories in cluster 1 when using the new cluster 2 program. The primary motivation to develop a new clustering approach was the computational time issue associated with clustering multiple years of trajectories. A simple test was constructed by computing 1,460 trajectories spanning the year 1990. The trajectory files are not available for download, but you can easily calculate your own. A script was used to run the original cluster and the new cluster 2 programs, which I placed in the temp directory. The standard program took about 8 minutes, while the new cluster 2 program took about 20 seconds. The new approach makes clustering large datasets possible. A comparison of the cluster mean trajectories shows some differences, primarily related to the treatment of trajectories associated with quickly varying wind conditions, an issue similar to the previous example calculation. An example of what can be accomplished with a faster clustering program is presented as a decadal climate analysis. 48-hour back trajectories were computed using global meteorological data 4 times a day for 612 locations around the world for 75 years, from 1950 through 2024. Approximately 15,000 trajectories per location per decade were clustered to evaluate if any climate trends were evident in the clusters. These results will be discussed in another video.